Bismillahirrahmanirrahim. This video is about three-phase transformers, and here primarily I'll be discussing example 2.9. So straight away head to the example. A 50 kVA 13800/208 volt delta wide distribution transformer has a resistance of 1% and a reactance of 7%, and we have to find these three questions. So the delta Y distribution transformer, as we know, will look like this. This is the primary side delta, and the secondary side is the Y connection. This is a line voltage, and this is a phase voltage. And similarly here, this is line voltage, and this is phase voltage of the secondary. So if we incorporate these values, it will be like this. So this is the power. Power remains same on both sides, the primary or secondary, 50 kVA. 13800 is the line-to-line voltage, and 208 is secondary line-to-line voltage. Now the first question is, what is the transformer phase impedance referred to the high voltage side? So we have to find impedance of one phase, impedance of any one phase. So the best is that we just take one single transformer or one phase of the transformer. So you can see from here what will happen. The power will be divided by 3 on both sides. This is line voltage, but in case of a delta, this is also the phase voltage. So this phase voltage will write 13800. In case of a Y, it will be different. The phase voltage will be less than 208. So 208 has to be divided by under root 3. And so the phase voltage of the secondary will be 120. Now, this is the formula for Z equivalent per unit. For that, we have to divide Z equivalent by Z base. Now, in this case, we have to calculate Z equivalent. So we need to find Z base, and Z equivalent PU is already given. We'll just see. Okay, to find Z base, we recall this formula. We know power is V square over R. So R is V square over P, and now here it is Z, so Z will be V square over P. So base impedance, Z base, is the V square, V base square, V base, this is V base, and divided by S base over 3. So this is S base over 3 power. Since the impedance is referred to the high voltage side, that is the primary side, we'll use V base as 1380. So we are going to use this one. Okay, so 13800 divided by this value. So the answer will be 11426. That is the base impedance. And now Z equivalent PU is given. We write from here, transformer has a resistance of 1% and a reactance of 7 per unit. This is given in the question. So this can be written as the per unit impedance of the transformer, Z equivalent PU, is 1% is 0.01 and 7% is 0.07 with a J because this is the reactive term. And now Z equivalent from here will be multiplication of the two. So multiplying these two terms, this and Z base. So this is our Z equivalent. The first part is done. Now the second part is saying that calculate the transformer voltage regulation at full load and 0.8 power factor lagging using the calculated high side impedance. So we'll use that impedance. First of all, let's recall the formula for the voltage regulation. So this is one of the formula, Vp divided by transformer ratio and minus Vs secondary voltage full load and V divided by Vs full load. To calculate the voltage regulation of a three-phase transformer, we have to determine the voltage regulation of any single phase, any single transformer. So we'll write this for the single transformer now. So we'll add phi with this. Vp will be now V phi P, and similarly the output Vs will be phi S. Now one more thing, in another book I had seen that instead of full load, it is writing rated. So this is more meaningful that it is actually the rated voltage. So I have copied this, we'll follow this. And this can further be simplified if you multiply numerator and denominator by A, then this will be our final equation. So we'll be using this for calculating VR. Now, this is our single phase transformer, primary, secondary, and the powers. So first of all, we'll calculate the turn ratio because we have to use turn ratio here. So turn ratio is V primary divided by V secondary. So it will be 115. Okay, now this is a simplified circuit which is used for calculating the voltage regulation. And in this case, we have to actually calculate Vp. Now, this was for the general three-phase circuit. Now, for our case, we'll just modify slightly. Vp will write now V phi P, and AVS will write AV phi S rated, and the current remains I phi. And we have also incorporated the value of Z equivalent here. So this is the R equivalent and this is X equivalent. Now, one more thing we have to find out, and that is the first of all, we need to find this current. So current we know is the power divided by voltage. So this is power, this one divided by this voltage, primary voltage. So this is our magnitude of the phase current, primary phase current. So it can be written as I phi. You can also write it as I phi primary rated, or you can also write it as I primary, but we'll follow this one. Now the magnitude we have found. To find the angle, we'll use this formula with power factor is given to be 0.8 lagging. So theta is cos inverse of 0.8. So it will be 36.87. And since it is lagging, therefore we have to use a negative sign. So in the phasor form, our phase current will be the magnitude and angle. Now we could have calculated the I phi from the secondary side as well. This divided by voltage will give us the secondary current, and secondary current divided by the turn ratio will give us the primary current. Anyway, this is just for your knowledge. So we were here, we had all the parameters. Now we can write the KVL equation. So KVL equation following this is our KVL equation. From here, V phi P will be this. Now we'll plug in the values. Turn ratio we already know is 115. And this term AV phi S is actually 115 multiplied by 120, so it will be 13800. So we'll use this in place of a AVS. Okay, so let's plug in the values. R equivalent 114 to I this is the value of I. Similarly, value of X multiplied by I. And finally, AV phi S rated is 13.8 angle 0. Solving with the help of your calculator in complex mode, you can directly solve. So this is the answer, or this is the primary phase voltage. Okay, now we can apply this formula for the voltage regulation. We know all the parameters. 14506, this is the magnitude only we are using. Similarly, the second one from here, 13800, we'll just use the magnitude divided by 13800. So VR will be 5.1%. Now we come to part C. We have to calculate the voltage regulation here under the same condition, but using the per unit system. So this was our circuit. We have to convert this into per unit. And for per unit, we know that we have to have the actual value divided by the base value. And if we take the primary voltage 13800 as the base voltage and the primary current 1.028, power divided by 138, it will get 1.028 as the base current. Then this one divided by 1380 will get 10. This will be the output voltage in pu. And similarly, current, this current divided by 1.028 will be 1 angle minus 36.8 in pu. So now we'll plug in these values in our circuit. We'll also plug in the resistance and reactance, which is already given in per unit in the question. So our new circuit will be current will be this value, output voltage 10, and resistance reactance 1% is actually 0.01 and 7% is 0.07. And now we can apply the KVL method to find V phase primary. So by KVL, from here we can write this. I hope you can follow this. The resistance multiplied by the current, reactance multiplied by current, and the output voltage. So this is our answer for the primary voltage. And now we can use the voltage regulation formula, same formula, except that the values are now different. So for VP or V phase P, it is 1.05, so we'll write that. This one AVS is 1 angle 0, we'll only write the magnitude. So it is 1.051 minus 1 divided by 1, and the value is 5.1%. So it's the same value that we got in the part B. I hope you have been able to follow this. Please let me know through your comments. Thank you.